Use transformations to graph the function. So the function you're given is y equals 5 sine of x, and then you want to use transformation to graph this function. I'm going to make a little sketch below. So you have something like this. Let's say you have y equals 5 sine of x. Y equals 5 sine of x. So you want to use transformation to graph this. So there are two things going on here. So the first is you have this is like your 1. This is the first function, and then the next operation is that you have 5 multiplying this. So the first thing I'm going to do is I'm going to first try and graph sine of x. Now when I graph sine of x, I'm going to carry out the next operation, which is 2, that says that multiply sine of x by 5. So for the first one, which is y equals the sine of x. Now to graph this, we recall that the sine of x has some properties. And what is that? The period of this, that is the period of the sine of x, the period. So the period equals 360 degrees. So when I say 360, I mean 2 times 180. So you all know what they call a period, right? A period is a cycle. When you say a cycle, this is 360 degrees. So that's a period. So and a period is 2 times 360 degrees is 2 times 180. So but if you want to write this in radians, this is going to be 2 times. So 180 in radians is pi. So y equals sine of x has a period of 2 pi. Now another thing we know, that this is one thing we know about y equals sine of x. Now another thing we know is that the range of y equals sine of x is from -1 to 1. You can't find the sign of a number and then you have the sign of maybe a number, you start having numbers like 2. It's not possible. This is very, very, very impossible. The highest number you can have for the sine of an angle is the highest number is 1, while the lowest number is -1. So that's why the range is from -1 to 1. Now I'm going to use these two informations to graph y equals sine of x because it's the shortest way. So let's say this is your Cartesian graph, and let's call this y and let's call this x. So what we know is it has to start here. Why does it have to start here? Now it starts here, which is 0, because we know that the sine of 0 is 0. So the sine of 0 is 0. So we know that. So at 0 is going to be 0. So it starts at the origin. Anyway, that's for sine graphs. Now, since the period is this, the period is 2 pi. So I'm going to use that knowledge. When they say a period, that is a cycle. So you have something like this. This is one cycle, like half of a circle. And then when you go another one, and this is a full circle. So instead of saying circle here, you call it cycle. So you call it cycle, or you say period. It could be seen as another name for circle. You understand? So we are told that a period is 2 pi. That is, by the time you would have gone through a whole length of a circle, you would have covered a distance of x equals 2 pi. So that is, this point here should be 2 pi. Now because this graph here is symmetric here, as you can see here, so if here is 2 pi and here is 0, then definitely here must be half of 0 to 2 pi. So here is going to be pi. And then how do we determine this point here? So because the graph is symmetric, so it's going to be the half of it. So pi plus 2 pi divided by 2 has to be 3 pi all over 2. Also, how do we determine the turning point here? So it's symmetric. So it has to be the midpoint between 0 and pi, and that will be pi all over 2. So similarly, if you wanted to join the remaining one, since you know from here to here is 2 pi, so the other cycle has to be -2 pi. So that is, if you have to go like this, it's going to be half, then this will be another half. So sorry, the graph is not drawn to scale, but you should understand what I mean. So this will be -2 pi. So this is going to be half of it, so it's going to be negative pi. While the turning point you have here is going to be negative 3 pi all over 2, while this point here is going to be negative pi all over 2. So my aim is this. I want to explain something before I move back to the question so that you will understand where I'm going to. Now, if this point here is 0, 0, so what's going to be the coordinate of this point here? It implies that when x is 0, y is 0. That's the coordinate of this point here. Now, for this point here, it says you can see when x is pi, what is y? Your y is 0. So this point here has a coordinate of pi equals pi 0. While this point here, it says when x is 2 pi, your y is still 0. It's still on this axis here, so that's to be 2 pi 0. Now, similarly for here too, you can also do the same thing. You can do the same thing here and here. But then how do I get the coordinate of this point? We have been told that the range of the graph is negative 1 to 1. That is, the highest it can possibly go is 1. So the highest is 1, while the lowest is negative 1. So having known that, it implies that at the points pi over 2, your y, because this is your sine graph, so let's write that down. That might be useful. Y equals the sine of x. This is the graph we are considering. So at this point here, when x equals pi over 2, your y is going to be 1. So the coordinate of this point here is going to be pi all over 2, 1. While this point here, the coordinate is going to be 3 pi all over 2, negative 1. So this is how the sine graph looks like. But then where are we going to? You know, our aim is we want to first graph y equals sine of x. The question demands we graph y equals 5 sine x using transformation. So for transformation, we do it step by step. Now I have graphed y equals sine of x. So the next thing I want to do is I want to graph y equals 5 sine of x. So let me use something else. You have 2 is y equals 5 sine of x. Now how do I make this transformation? Now a very good way to read this is that it says multiply the y coordinates by what? By 5. So multiply the y coordinates by 5. That's what it means. Y equals 5. So that is the y coordinate. Multiply the y. You know, this is another function here. The other function here is y. This is the y of another function. So you have y equals 5y. That is, the new y is going to be 5 times the original y. So to find my new y, so all the y's I have here, I have to multiply them by 5. So what you have here is negative 1. So this will be multiplied by 5. This will be multiplied by 5. Sorry, multiplied by 5. Multiplied by 5. This will be multiplied by 5. The same thing here, multiplied by 5. So 0, this is, and on like that. So let's do this demonstration. Now, when you multiply 0 by 5, so you note the x coordinate stays the way it is. It only affects the y coordinate. So when you multiply the y coordinate by 5, 0 times 5 is still 0. So nothing happens to the origin. It stays the way it is. When you multiply this one by 5, the new coordinate you obtain is going to be pi. So it's going to be pi. This should be pi all over 2, comma 5. This is going to be the new coordinate. So since the y coordinate is 5, corresponding to this, so it should be somewhere here. Let's say this is going to be a new 5. So the graph is going to shift to this place here. So this is going to be pi all over 2, 5. So for the next one, which is this point here, it says multiply 0 by 5. 0 by 5 is still 0, so it's still going to be pi 0, so it does not move. The next point is negative 1 times 5, so this becomes 3 pi all over 2, comma, negative 1 times 5 is going to be negative 5. So that is when x is 3 pi all over 2, when x is this, your y is negative 5. So but initially y is negative 1, so for y to be negative 5, it has to move down. So this is going to be a new point. So for this point here, you have 0. When y is 0, you multiply by 5, you have 2 pi 0, so it does not change. So how do I join this? So this is the new graph. You can see this is a stretch. That's why it's called a stretch. So it goes like this. It goes like this. Like that. So this is the new graph. Y equals 5 sine of x. So you can do the same thing for this too, because it's symmetric. So this is just going to be here. So this goes like this and goes like this. Then the same thing happens here too. This one goes to 5. Then you join this. You join this. So you note all the points on the x-axis, they stay the way they are. So this is how it's been derived anyway, using transformation. So all you need to do is just bring them back here. So since what you have here is this, so we are using 5, and then this is pi. So this is pi here. So we move from here like we did there. So this is where it crosses. So this is -5. So we go, this is pi over 2. Pi over 2. So we move like this, and then we come down, then we go down to this point here. It must correspond. Then we go. So we do the same thing for the other side. Anyway, that's how it's been derived. I do hope you understand. But if you have questions, do not forget to drop your questions in the comment box below.